I said to you now, I feel like a fool too. I feel like I'm blue.
Hi everyone, welcome back. This is Mike Makers with you today. We make a new tutorial on how to create a digital sensor to measure distances. It's made with an Arduino and a HCSR05. I think that's the name of it. HCSR05. So the name is in the description of the video. So on the lower right, I want to show you distances. So this sensor can measure distance from 4 centimeters to 30 centimeters. I don't have the real distance in my head to be real with you, but I just want to show you something. So have a look on the screen on the bottom right. So have a look here. This is my hand. So it says now we got like 6 centimeters. Let me see. So it's about that. So the further I go, the more it goes. Like here we got 15 centimeters, 13 centimeters. So that's more or less it. So in the tutorial to show you today, I show you how to do these simple things. So the schematic is pretty simple, and we have the sensor here and a few cables and Arduino Uno board, so it's gonna be pretty simple. So let's get started. As I said, schematic is really not too difficult. So it works with an Arduino Uno, so you can see the schematic at the bottom right. It works with Arduino Uno. It works also with the HC-SR04. I'm sorry. So you can see on the screen I found this data sheet on the internet, so you can just type datasheet HCSL04. So this component got two main parts on it. You got one, you can see you got all these grills on it. So it wants to emit and want to receive the waveform. So one gonna be the trigger and one gonna be the echo. So here we go. You need alimentation. It's going to be 5 volt GND. So you can plug this on plus 5 volt on the Arduino Uno GND, and you get the trigger here, and you also have the echo here. So this is more or less how it works. So you put a salve of 10 microseconds on the trigger pin during and it will send a waveform, and when sending this waveform, it sends the waveform, and when the waveform meets an obstacle, it sends it back. It's like a radar. That's a radar actually. It's like a radar, and the time it takes to go back and forth. This is how long it takes to. This is how long it takes to do the travel, and you can divide this by 2 since it takes a certain time to go and back, so it's multiplied by 2, so you can divide it by 2. So let's have a look on the screen here on at the bottom right. So I show you pretty quick what I did. So have a look here. So that's the formula for the speed. So the speed equal the distance in meter. Yeah, I'm doing it in meter. Distance in meter by the time in seconds. So the time in seconds. This is the speed of the sound. So this is 340 meters per second. So this we know this. And the speed gonna be the time you're gonna spend. Okay, let me go back here. So there we go. So what we need is the distance. So we're gonna have the time, the speed, and the time it takes to go back and forth. So distance equal the speed by the time. That's gonna be it. Now let's go back to Now let's go back to the screen here. I was saying, there we go. Let's go back to that. So here we are. So we got the trigger pin, so we put it on 8 on 9, echo pin 8, the time for it to travel, and the distance. These are the variables. So, and we put the trigger pin, the echo pin, input and output because we're going out, and input is coming back, and we put the serial communication too, because I want to see the distance. So we're gonna work with the serial monitor here. So we're gonna trigger at low, the pin at low. So we're set to start. I can say that during two seconds. So it has start, and after that, when it start, boom, I put it at 1 here, and I wait 10 microseconds. I'm sorry, and after that I turn it low. And let's see here, we use the pulse in function on the echo pin. So now we're just waiting, and when it detects something, we're gonna have a high level. So and we'll be able to figure out the time it took to go back and forth. And this time we multiply it by the 0.034 microsecond. So this represents, I just showed you before, 340 meter per second. This is the time the sound travel in the air. But it's meter per second, and it's gonna take some times. And if we go closer, we're not gonna have it in meter per second. You're gonna have it like in centimeters maybe per millisecond. So it's gonna be shorter. So this is a conversion of meter by centimeters here, and so by microseconds, and we divide it by per 2 because it goes back and forth. So we only want the distance. We don't want it goes and it goes back. So we have the round trip. So we need to divide it by 2 when you want one distance. And here we put it in distance variable. After that we go to serial print distance in centimeters and serial print distance. And after that here we arrive at 1 sec. We put a delay, and the loop, we go back and forth like this every 1 second to show us the value. So let's go to serial monitor, just right here. Oh, there we go, here. 28, 27. There we go. So now I'm moving my hand. Okay, it may be disconnected now. I'm moving my hand. Yeah, it knows. So as I show you at the beginning, so have a look at the bottom of the screen on the right, so you can see how it evolves. That's nice. So that's pretty simple because you don't need a breadboard to do this project. So that's the end of the tutorial for today. So I hope you really enjoyed. If that's the case, please subscribe if you haven't done it. Like the video. Like, you can also look the other videos. So if you want to have an LCD screen, I also have a tutorial on LCD screen, so you can do that too. I also have other tutorials too. Have a look, check all the tutorials, like them, share them with your friends, and subscribe. For sure, subscribe. And by waiting that time, see you soon for another tutorial. I mean next week.
That you basically just
Thank you very
run
much.
into whenever things go wrong.
How can get you on my mind?